2.8, graphing linear inequalities. I left it till we got into chapter 3 to make sure we're solid graphing lines before we start worrying about graphing inequalities. So if you're not an expert at graphing lines from both slope-intercept form and from standard form, I recommend you make sure you're really good before you do this section. So we're going to talk about how they're different from the graphs of equations. We'll talk about shading and solid versus dashed, and then what really is the answer. X minus y is greater than 4. Okay, I've got an inequality, so it's got a greater than sign, and we're going to talk about, we could put this in slope-intercept form, but it's a nice candidate for graphing using intercepts, so I'm going to use my cover-up, and graph using intercepts. I know that my y-intercept is going to have a 0 for the x. It's going to be on the y-axis. If I cover up that x, I'm going to get -4. If you're not sure how I got that, I would go back and review one of the 2.3 videos on graphing from standard form. So there's my y-intercept. My x-intercept, I know I've got a 0 for y. That's going to be my x-intercept. It's going to be the point on the x-axis. And again, when I'm doing this, I'm just pretending it's an equality for a second. So this time, if I put 0 in for y, I get x equals 4. So I can graph those 2 points. -4 on the y-axis and 4 on the x-axis. Now if it was a line, we would just graph a line. But since it's got greater than, if it has greater than or less than, if we were doing this on a number line, remember that would be an open dot. Well, the equivalent of an open dot here is going to be a dashed line, right? So it's just kind of open. It's just a line. So the best way I do these, if I'm doing these on paper, I'll often just do a whole line. If I have a good eraser handy, do the whole line and then erase. In fact, I think I'll do that here. I have an eraser handy. So I can tell by this that the slope of this line is 1 because it's going through all those nice little intersections. And then I'm just going to take my eraser, let me make it a little smaller. I'm just going to take my eraser and make it a dashed line. Because it's not equal to. That line is not part of my solution. If it was equal, that would be my solution. Now, it's going to either be, oh, let's make that fatter. That's either going to be this half, or it's going to be this half. One half or the other. So we have to figure out which half it is. And that's really the only new thing, is where do I shade? And the solid versus dash thing. As long as I'm here, let me put that if it was less than or equal to, or greater than or equal to, if we were doing number lines, that would be a solid dot, and here it would be a solid line. So that's what takes care of the line. Now we got to figure out which way to shade. And a lot of people know some kind of shortcut using the direction the inequality is pointing, but unless you did 100% perfect on all those number line oriented quizzes, I would recommend you do the test point method. So how do we pick a test point? Well, we said that it's always going to be a half plane that's shaded. Either it's, one half of the coordinate plane or the other. In this case, you can think of it as above or below that line, or to the left or right of that line. It's a slanted line, so it's kind of hard to say above or below. So we're going to pick a test point, and if 0, 0 is not on your line, then that's a good test point to pick. So we're going to pick 0, 0 if it's not on the line. And I'm just going to stick that in. So my equation would be 0 minus 0 is greater than 4. 0 is greater than 4. Is that true? No, that's false. So that means I'm pretty sure I'm going to shade this way. Right? I think that's this half plane that's shaded. If you have colored pencils, this is a great time to break them out. So I think we're going to shade that part. But just to be sure, I'm going to pick a point in there. I could pick any point in there. I could pick this point, or this point, or this point, or this point. Every single point, and I could even pick fraction points, but that would be kind of silly and a lot of work. So I'm just going to pick something I know for sure in there. Let's say, 8, negative 8. I think this is 8, negative 8 right here somewhere. So let's say 8, negative 8. So I'm going to use 8, negative 8. I'm just going to pick any point that I think is in my solution area. And so I would have x minus y is greater than 4. So that would be 8 minus negative 8 is greater than 4, which should be 16 is greater than 4. That's true. So that means I want to definitely shade the half plane that includes 8, negative 8. So I shaded correctly. So I would recommend you use that test point method. 3x plus 6y is less than or equal to 12. Okay, so I'm going to use my x and y intercept. I like to do my y-intercept first because I'm so used to seeing 0 something. So whether I'm using slope intercept form or graphing using intercepts, I have 0 something. If I stick a 0 in for x, then I know y would be 2 to make that equal. Again, when I'm doing this part, I'm pretending it's equal. To get my x-intercept, I'm going to stick a 0 in for y. If I stick a 0 in for y, I get 4. So this time my y-intercept is positive 4, and my x-intercept is y-intercept is positive 2, x-intercept is positive 4. This time my line is solid because it's got that equal on it. Looks like my slope is negative 1/2. Don't need to know that to do this problem, but that's just good habit because it helps me do my line more accurately. I can keep going up 1 over 2, up 1 over 2. Right, this is not a new concept, it's just an extension of the same concept. Now 0, 0 is clearly on one side of my line, so I'm going to try 0, 0 as my test point. And if I get a true answer, I shade that side. If I don't get a true answer, I would check the other side just to make sure. So 3x plus 6y is less than or equal to 12. If I stick a 0 in, it's 3 times 0 is 0, and 6 times 0 is 0. That's why I really recommend 0, 0, because how much easier could the math be? I probably didn't even need that middle line. 0 is less than or equal to 12? True. So I'm going to shade the side this time that includes 0, 0. Right? Some people, forget it goes right up to that, and the half plane goes on forever, so it's going to keep going in that direction. I don't have to stop the edge, but well, let's hope you have it because it's gone now. Let's do one that's in slope-intercept form. Less than or equal to 4x minus 1. So this time I've got my y-intercept and my slope. And again, since I'm going to be graphing, I'm going to think of my slope as a fraction. Now I can graph that line. This one's going to be solid again. They're not all going to be solid. The first one was dashed, but this one has that equals on it. So up 4, down 4. Very steep line. Up 4, 1, 2, 3, 4 over 1. So a very steep line. And now I'll try a test point. Now, 0, 0 I know is to the left of that line, but again, you don't always have to pick 0, 0. I'm going to pick, again, I'm going to pick something either clearly over here or clearly over here. Let's, I'm going to pick the blue dot. Okay, the blue dot is 1, 2, 3, 4, negative 3. 4, negative 3. Okay, I'm going to pick the blue dot. It's 4, negative 3. So I'm going to take that and I'm going to plug it into my original equation. Y is less than or equal to 4 times x minus 1. My y is negative 3. My x is 4. Negative 3 is less than or equal to 16 minus 1. Negative 3 is less than or equal to 15. That's true. So I'm pretty sure I'm going to shade the side that includes that point. I picked the blue point, so I'm going to shade this way. Again, you don't want it to be too dark. And then I got cut off on the last one, but I'm going to check the red point just in case. That red point looks like it's negative 4, 3. So if I plug that in, y is less than or equal to 4 times something minus 1. Now I have this is positive and this is negative. 3 is less than or equal to negative 16 minus 1. 3 is less than or equal to negative 17. Nope. So that's why we shaded where the blue dot was. So that's how you do that with a test point. What about those special case lines that are like this? Okay, well that's a horizontal line. And here, I don't really think you need to do a test point. Here's the line y equals 2. I did it dashed because that does not say equal. And then where is y less than 2? Y is less than 2 down here. And I'll do an x line. X is greater than 4. Well, here's the line x equals 4. It's going to do it dashed because there's no equal there. And then where are the x values greater than 4? They're greater than 4 over here. So you're shading with a colored pencil, or you're shading lightly with your pencil, or coloring with a highlighter. And so it's that half plane. And you might be thinking, well, that's not a half of the plane, but remember, everything goes on forever. So it is half the plane. How are inequalities graphs different than equations? Equation is just that line. Now everything in that shaded area is a solution. So you have lots and lots and lots of solutions. All the shaded area is your solution. Can I shade by following the arrow? No, pick a test point. How do I know if the line is solid or dashed, whether it has the equal or not, and what part is the answer? Remember, the whole shaded part is your answer.